my darlings. Today we are going to go over our 7.5 notes, which is adding and subtracting our rationals. So how do we simplify a rational expression? By adding and subtracting. So of course, first we're going to review with just adding and subtracting fractions with numbers. You should know how to do this already, but just to refresh your memory, in order to add and subtract fractions, you have to have a common denominator. Once you have that common denominator, you're just going to add or subtract those numerators, and you're going to keep that common denominator the same. Okay, if you don't have the least common denominator, you just want to make sure that your final answer is always simplified. So here we go. In example A for the review, we have 3/7 minus 6/5. So our common denominator there would be 35. 7 times 5 is 35. So I'm rewriting those two fractions with those common denominators of 35. So of course at this point, you know you need to change your numerator. Well, what did you do to 3/7 to make it something over 35? You multiplied that top and that bottom by 5. So multiply my top by 5, now I have that 15/35 minus, what did I do to the 6/5 to get that denominator of 35? I multiplied by 7. So multiplying that 6 by 7, I get 42 in my new numerator. And so now I can just subtract. 15 minus 42 is going to be a negative 27, still over that 35. I want to ask myself, can I reduce this fraction? And the answer to that is no. So there's my final answer. Now in part B, notice we have that 5/12 plus a 1/18. Well, instead of doing 12 times 18 to get some big old common denominator, let's look at the factors of 12 and the factors of 18. I know that 12 is really 2 times 6, or 3 times 4, whatever you want to think about. Plus, I know that 18 is 3 times 6. So think about what you're missing on either side. You know that you have a 6 on both in both denominators, both factors of those denominators. So if I multiply this by 3/3 and this one by 2/2, I would be getting the same denominator for both of those fractions. 3 times 2 times 6. 3 times 6 times 2. That would give me that product of 36 for that common denominator. And now it's making my math just a little bit easier. I know that 3 times 5 is 15. I know that 1 times 2 is 2. And so now I just have 15 plus 2, which is 17/36, which again cannot be reduced. If you didn't see it that way, you could have done both sides by, multiplying one side by 18, multiplying the other one by 12. You would have gotten some really big numbers in your numerators, and then you would have had to simplify a lot at the end. This is just making your life a little bit easier, and this is actually how we're going to work it when we don't just have numbers and we have actual expressions in our numerator and our denominator. Remember, you always have to factor first. So I'm kind of factoring these denominators to see what I need to multiply by for each fraction. So now let's go ahead and try it with some expressions like I said earlier. We want to find the sum or the difference. So remember, you have to have that common denominator. Once you have that common denominator, you can just add or subtract those numerators and simplify any way that you can. In example 1 part A, do we have the same denominator? Yes. So we're lucky in the fact that we can just start subtracting our numerators. So now we just have 3 minus all of that 3x minus 4. Be careful there, because at this point I want to subtract everything inside parentheses, so it's really like I'm distributing that negative. So I really have 3 minus 3x plus 4, which is a negative 3x plus 7 over x squared. Okay, at this point nothing can cancel out, nothing can simplify. But we need to remember that this is still a fraction. So we still have to kind of list our excluded values. And right here, that means that our x value could not equal 0, because if x was 0, it would be undefined. All right, let's going over to part B. Now this time, do we have the same denominator? No. So what are we going to do first? We're going to factor. Okay, so I'm going to go ahead and factor both of those fractions. I have an x plus 2 over. In my denominator, I can pull out a GCF. So I have 2 times x minus 1 minus that negative 2x minus 1. I'm going to go ahead and just take out that negative, leaving me with 2x plus 1 over. Okay, so I want factors of 3 that add up to negative 4. That's going to be a negative 3 and a negative 1. So it'll be x minus 3, x minus 1. So now that everything's factored, I want to create that common denominator. So look at those two denominators. I have a 2, x minus 1. I have an x minus 3 and an x minus 1. Well, they both have this x minus 1 in common. So what is each other side missing? Well, this right-hand side is missing a 2, so I can multiply this side by a 2. And this left-hand side is missing that x minus 3. And so now I have both fractions having the same exact denominator. Now remember, what you do on the top, you have to do on the bottom, vice versa. So because I multiplied a 2 at the bottom, that means I also need to multiply by a 2 at the top. And because I multiplied by an x minus 3 at the bottom, I need to multiply by an x minus 3 at the top. So let me just rewrite this so it looks very nice. Notice we have that common denominator now, so I can just make this one fraction. In my denominator, I have 2, x minus 1, x minus 3. In my numerator, I have x minus 3, x plus 2. But then I'm subtracting a negative, so obviously that just becomes a positive, plus 2x plus 1 times 2. Okay, and so I like to just expand this out so I can combine all my like terms and then simplify as much as I can. So I know that I now have an x squared minus x minus 6 plus, go ahead and distribute that too. That's a 4x plus 2 all over. Still going to leave it like this. You'll see why in a little bit. Okay. And so in my numerator, combining like terms, I now have x squared plus 3x minus 4. And then I know in my numerator, I can factor that out to just x plus 4, x minus 1 over this 2 times x minus 1, x minus 3. And then now you should see, oh, look, I can cancel out those x minus 1s. So now I just have x plus 4 over 2 times x minus 3. So that would be our final answer. It is simplified. However, going back to that domain restriction, x could not equal 1 and x could not equal 3. Okay, so our next one, you know that we have to factor first to help us find that common denominator. So we have, switch colors, we have x over. That is going to factor into x minus 4 and x plus 3 plus 5 over 12 times x minus 4. And so as you can see here, what are we going to have to multiply to each side to get that common denominator? Well, this side needs an x plus 3. And then this side would need a 12. And so now our common denominator is going to be 12 times x minus 4, x plus 3. And so then combining our numerators, we would have a 12x plus 5 times x plus 3. At this point, you should kind of pick up on some patterns and you should immediately see that your domain restrictions, x cannot equal 4 and x cannot equal negative 3. All right, but we can start combining like terms and we can see if anything cancels out. So if you wanted to, you could turn this into, now if I distribute that 5, that would give me 5x plus 15. So I'd have a 12x plus 5x plus 15. So 12x plus 5x would give me 17x plus 15. Then we can just leave it as this 12 times x minus 4, x plus 3, and that's fine for right now. Okie dokie, and then let's go here. Again, gotta factor first. So we have 7. I know 9x doesn't look like it could be simplified, but really that's 3x times 3x. 3x times 3x plus x over, what's our common factor here, GCF, 3x. And then that leaves us with x plus 1. So notice we have 2 3x's on that left-hand side. We have 1 3x on the right-hand side. So that means that right-hand side needs 1 more 3x, and then that left-hand side just needs that x plus 1. So this side is going to have that x plus 1 being multiplied to it, and then this side will have that 3x being multiplied to it. Coming down here, that's going to give us 7 times x plus 1 plus 3x times x over, that's really just 9x squared times x plus 1. Combining our top, I could distribute that 7 and get 7x plus, sorry about that. I could just get 7x plus 1, and then that would be 7x plus 7 plus 3x squared. So that's just, and you could write it in standard form. Okay, and so then our exclusions would be x cannot be 0 and x cannot be -1. Okay, and then for problem E, we know that, I keep saying factor first, but notice that's only necessary for our denominators, not necessarily necessary for our numerators. And if we look at part E, x squared plus x minus 27 is not factorable. And there's really no need for us to, take it to the next step and try to do the quadratic formula or whatever, because we're solely focused on trying to find that common denominator and just combining the like terms in our numerator. So notice our denominators are almost the exact same thing. They're just a teeny tiny little bit different. So we have this x squared plus x minus 27 over x minus 4, and then we have an x squared minus 8x plus 9 over 4 minus x. Well, if I were to rewrite that as negative x plus 4 as that denominator, what I can do is I can factor out that negative, and now I almost have that same denominator. I just need to multiply that left-hand fraction by a negative. So when I multiply this left-hand fraction by a negative over a negative, that's going to give me a negative x squared minus x plus 27 over negative x minus 4 plus the x squared minus 8x plus 9. Remember, that whole entire numerator has to get multiplied by that negative, so I distributed it to everybody in that trinomial. That's what got me that negative x squared minus x minus 27. Well, if I'm combining those numerators now that I have the same denominator, my x squareds are going to cancel out. Negative x squared plus x squared cancel out. Negative x minus 8x, that's a negative 9x, plus 27 plus 9, that's a plus 36. There's our final answer. What are our exclusions? X cannot be 4. 1, oh no.